Hello, everybody, and welcome to my class. If you don't know me already, my name is Mr. Alexander, or Action Jackson, or Coach. And today I'm going to be teaching you a little bit about physics. All right, today we're going to go over a quick overview of Newton's laws, and then I'm also going to break down and tell you the components of each one of his laws. All right, so Newton's first law: an object at rest stays at rest, and an object in motion stays in motion until acted upon by another force. His second law basically just gives us the formula F equals m times A. Well, what does that mean? That means force equals mass times acceleration. And then lastly, we have his third law. For each action, there is an opposite and equal reaction. Now, what do each one of these mean, and how do they really apply to each other? All right, so let's go ahead and break this down. An object, all right, an object can be anything. For example, the two balls that I've been holding. All right, an object can be yourself, an object can be your car, anything. An object's anything that you want it to be in relativity. Then it says an object at rest. What does rest exactly mean? Rest is defined as the object just staying put, not having any force acting upon it, and it just having no acceleration and no velocity. The velocity being zero, so it's sitting perfectly still. All right? An object in motion, the velocity and acceleration, or the velocity is just, it's going to be a number. It's going to be something greater than zero. Or it can even be negative if the object's moving backwards. So, and then it's saying that they're going to stay moving or stay sitting until something else acts upon it. All right? Well, if something else acting upon it is the force. Well, what exactly is a force? There are many different things that a force can be. A force can be anything from me hitting something, throwing something, these two things hitting each other, gravity, air, friction. Friction's also one. And there's tons of other things that are a force. All right. And then, so this all helps us. And then this gives us the equation. And the equation is just telling you how to find the force of an object, or how much of a force does something have. All right. So to find this, you'd end up, like, if we wanted to find the force that I threw the ball with, we'd first need to measure how much the ball weighs, or its mass. Then we need to see how fast I threw it, which is the acceleration or the velocity. And then times those together, and you end up getting the force. All right. And then for the third law, for each action, there's an opposite and equal reaction. All right. This is saying that, like, in a car crash, cars are actually built to withstand the crash, and they buckle, and like how the front end of a car gets crushed. So like when they're both running into each other. So if a car crashed into another car at 10 miles an hour, normally if they were both just two solid objects, and this one was sitting still and this one was moving, it would hit it and make this object go back, being the opposite reaction. All right. So for every action, there's an opposite and equal reaction. For the force that I throw the ball with, there's a force that's pushing back on my hand. All right. And that force would be the force that we would need to overcome to put something into motion. Kind of like a ball rolling down a hill. Like it rolls kind of slow at first and then picks up speed because it's having to overcome the force acting upon it, keeping it still. All right. And then in the next video, I'll show you more about, I'll show you the experiments we can do with this.